This is the material world and what its values, etc., all those kinds of things. This video is more on the physics of the real, the physical world. What we call the real world is the physical world. The spiritual world is what we can think of as the emotional, the mental, the imaginary and such, which it exists. It's real in even in a measurable way. If you look into electromagnetics and such, really scientists aren't getting paid to look into the spiritual world, so we don't really have much information on it. You just have a couple people in their basements doing experiments. Hence why it's not really it's not really much of a thing that science really cares about or recognizes. But going on, physically things are in patterns usually. Physically, if you look at minerals, they're in patterns. They have these geometrical structures and such, and matter has to take a physical form. Once you physicalize something, you've slowed it down essentially. If you think of water's like the movement. It's like a physical form that can move. It's a physical form, in a higher vibration, people like to think. And then air being very quick, all these things, but air can't pass through a wall. If the wall is solid, it can't really pass through it. So even air has limitations. It's not really until you start going to higher levels of electromagnetism and such, or heat. Heat can pass through a wall, so to speak. It can heat the wall up and can pass through it that way. Electromagnetism, depending on what the wall is made out of, depending on how dense it is, can also penetrate it, or sometimes cannot penetrate it. So the physical world has physical rules. This is what we call physics. If you touch something physical, you can't push your finger through it unless it's jelly or pudding or goo or something like that, unless it's has some liquid or water element properties to it. It's gonna be a physical object. Density is a law of physics. Not a law of physics. Density is like a thing. It's an attribute of physical objects. The denser something is, usually the heavier it is. If you look at a thing like aerogel, which is basically, you have shaving foam or whipped cream or whatever, things that are in a colloidal state, which is means suspended in liquid, so to speak. You then spray it out and it goes. It's the same thing with a propane gas, which is in a liquid form. All solvents in spray bottles are in a liquid form, and then you spray it and it makes it. It goes really big. So shaving foams are not very dense. It's very light. A propane gas or a varnish spray or an oil spray or whatever is not very dense. It's very light. And that's how you can, if you learn the rules of physics, you can make super light materials because they're not very dense. They're not very heavy, because they're not dense. So you can make these things. If you make a super strong aerogel, which is as strong as, steel or titanium or diamond, then, you've basically made a super material. And the material science is a part of all this physics stuff. It's a part of understanding the physical world. Plastics is a very interesting one. Plastics being this, they take these compounds like ethene or something like ethylene or whatever, which, it's you think ethyl alcohol, it's related to that, but it's made from a mineral oil, like a mineral volatile or something, and they somehow mix it with catalyst and all to make a powder. But a lot of it acts like a gum. And if you make toffee, for example, a simple toffee is just sugar and butter. The butter kind of gives it the form. The toffee acts to crystallize it, and it's like sugar. You keep heating it together and the toffee turns into a gelatinous material, a gooey kind of thick material. Eventually you keep heating it, and you get a solid. Once it cools, you get a solid material, and if you heat it too much, it smells like plastic. It has this weird plasticky smell. At least when I made it, I cooked it too long, and it smelled weird as. Toffee's like a plant-based polymer, I guess. Molecularly, I don't know if it actually has, polymer being the chains of carbon and hydrogen. So I don't really know if it actually is, but it functions like one. It functions similar to a glass. Plastic is similar to glasses. It's like a resinous glass. You can have see-through plastic, which is replaces the need for glasses and such. And then if you look into like fiberglassing, which is just where you take a sheet of like fabric. I use this like plastic fabric, and then you just use the resin to harden it. Right here I have these pieces of what are meant to be plastic electrolytes, and it's toilet paper with PVC glue on it, which is, I think they call it paper mache, and the part of the toilet paper has kind of become invisible. It's like lost its organic plantish, plant fiber ways, which again, paper was made by, mashing a bunch of plant fibers, which is, stems and leaves and all this in, and you boil it in lye to get all the oils and all the salts and all this stuff out of it. Again, relating to alchemy, when you boil things in lye, it's like a alkaloid extraction to get all the crystals out of, essentially, or you're just getting the resins out of it, and then they mash it into small sheets, and then it's how they make a crude form of paper. So it's toilet paper and PVC is paper mache, and it's actually interesting. It's like a plastic sheet, or like a rubber, not rubber, but like plastic piece of thin film almost. It's interesting. So these are materials, and if we look at like lead and uranium and super heavy metals are. You take the ore and you basically have to heat it to an incredible level. Or something like aluminum, they do a electrolysis process, which is actually just what they're doing is they're electrically heating it. So they've got a bunch of salt as like the electrolyte, I think, like molten salt and aluminum crystal, powdered crystal, and then they just have like carbon electrodes, I would imagine, just crap loads of amperage, and it creates a sea of just aluminum metal. Like jelly molten aluminum metal, it's in that liquid form, in that liquid metallic form. And again, that's just, if you take a crystal and you heat it, again, you release the water first, and then secondly, you release whatever chemical is on it. So a salt crystal, like a sodium something, or a chloride crystal, you release the chlorine, atomically you're thinking that, or just it releases the gas actually. And which actually it's an oil. It's kind of like an oil, I think, like a resinous. I'm not actually completely sure. At least with sulfur, I think it could be like you take an iron sulfate and you heat it up. You get rid of the water which is in the crystals, which is kind of weird, and then you get rid of the sulfur, and then you just have this iron. I don't know. It's an iron like oxide, or just like a crude brown iron powder, and you get that from a crystal. So that's kind of how forging metal works. And then you're basically just heating things, so just heat. Of course, heating things, and the opposite of that is using liquids. So fire and water is the refining methods, and liquids could be acids. Strong water is an acid. Strong fire is a flame, I guess, a superheated flame, which is what you use to process things. Of course, you've got your categories of physical things. You've got things like metals, plastics, glasses, which are any kind of crystal. Crystals are glasses, if you didn't know. And they're just glass, silicon, oxygen kind of things with metal salts in them to color them, essentially, and they're naturally forming. Otherwise, you have woods as well. You have dirt, things like just regular dirt, clay, maybe calcium, like deposits, just deposits of earth, sulfur deposits. They're all kind of related to dirt. So I would say, I guess, organic plant. I guess plant materials, but also animal things like furs, etc. And all of these things have qualities. Now, wood is an interesting one if you want to study physical things. Different kinds of woods are hot and different kinds of woods are cold and kind of medium temperature. Touch wood when it's a cold day and see if the wood is colder than the air, or touch it if it's a hot day. If you leave metal outside in the sun, it will become hot. If you leave wood outside in the sun, it'll become warm. I am sitting on very dense wood right now, and it is cold. I can feel my butt is cold, even though I have something to insulate. And insulation, again, that's a property of the physical realm. I'm using a kind of folded up blanket made out of plastic, I think. I don't know if it's cotton, plastic mixture. Usually, for your own health, you should try to avoid any kind of plastic anything. Plastic clothing, not good. You know, static electricity, etc., etc. But going on, so one of the woods that I'm sitting on is cold. It's very dense. It's very heavy. It's hard to work with. It's a pain in the ass. And another wood in this chair is actually light. It's like house construction frame wood that I found. It's kind of crap because it just crumbles and it's so easy to break, and which makes it easy to work with and easy to cut and all that stuff. And it's warmer. It's warmer. So does density make things colder? Lead is cold as ice. Is iron or aluminum is less cold than lead. Now I haven't had a solid piece of aluminum, so again, the form of the metal potentially changes the ability to conduct heat. So if you've ever taken a shitload of acid, you will probably have understood the interwoven fabric, quantized positive, negative, nature of reality, where you can just see into everything like a microscope. If you haven't, well, I'll try to explain. Essentially, I don't recommend you do that. By the way, this isn't it's just what happens when you take a psychedelic. It's just what happens. Going on, basically, physical material reality is just is fabric. It's like fabric. Fabric is just interwoven pieces of horizontal and vertical strings. That's fabric, and then they pull it tight and they make a fabric. And it's just finer, thinner fabric is just smaller strands pulled together. Heavier fabric is thicker pieces. You've got a thick woolen scarf someone knits because the pieces of wool are thick. The entire reality is like that. It's just interwoven fabric. Everything's just interwoven fabric in the material world. And if you want to create something, it runs off these laws. When you densify things into the physical world, it runs off laws. Now, of course, you can still dip the spiritual world into things. You can charge things with mental energy and curse things and such, and it'll cause weird effects that don't exist within the physical, boundaries of physical laws and physics and such. Assuming things are stable, then they will follow laws. Water will sit in a cup stably. Objects will sit on a table stably. That's just how things work. Once you start, you see the next realm beyond the physical realm is like the human realm. You can think the social, you're getting more into emotions. It's starting to become more stimulated. It's the world of societies. Society, people are moving around. They're driving cars and vehicles. They're moving objects, eating food, all this stuff. There's this activity, or the world of Earth is stabler. Objects is stabler. Dead objects that just sit there. Minerals that slowly grow. Plants that slowly grow. And if you look at animals, they move around. They're a little more animated. So that's the next world. And the world beyond that is the mental world. And the internet is, of course, your computers. It's a physical. Any kind of like electromagnetic device is like a physical representation of the third world, the highest world in this specific example. So that's how these things all fit together. So going on, when you make physical objects, for example, a paper or a foil, they're all sheets. They're sheet-based objects. So there's different shapes of objects. Shapes are a primary factor of the material physical world. If you get what I'm saying, is in things can be made into different shapes. Box is a common shape. A house is made out of box. Furniture is basically made out of boxes. Cabinets are made out of boxes. Storing anything is basically a box. A thing that you need to write on, or a thing that you need to wrap with, is a sheet. Tape is a sheet. It's just a sheet, a long sheet, and you then have the wire shape. I'm looking at, like, right near me, I have electrical wire. And headphone cabling, mouse cabling. It's in a cylindrical wire shape. This is another archetypal shape. And anything that needs to travel, like a water pipe, pipe, it's the same shape. I've solder near me, it's just convenient in that shape. Otherwise you'd use like a strip or something, but it probably wouldn't be accurate enough. So the shape of things is important, and understanding how to flatten things down to a sheet or to thicken things up into like a box or cylinder or whatever is important. And the shape of things will influence how stable something is. A square is the most stable shape, but of course, as the Romans show us, an arch is also very good. An arch works well. So if you look at buildings, infrastructure, a couple of days ago I was walking over a bridge, which is essentially over what we call the freeway, or the area of space, the road where cars drive very, very fast. And there is it's just basically a long slab of concrete, and I imagine there's probably metal and mesh and all that inside of it. And I was thinking, really, how safe is this, to be completely honest? How safe is this infrastructure? Could I just fall through this piece of concrete, crash into those cars? Like, honestly, it's a bit sketchy. Especially at night, when you got all those cars underneath you, it's very anxiety-inducing. But anyway, going on. So, of course, the material of the object will decide what you use it for. A kind of rubbery material for bike wheels, for example, or car wheels or whatever, is a decent material. Of course, there are wheels that are like, physical solid wheels that punctures don't, harm. There's tank treads. There's also all kinds of other wheels. So, what is the best material for what you're doing? If you need a house to be waterproof, usually in the past we've used like different kinds of waterproof plasters and metals and such, woods with varnishes and all that. So you need it to work. Now, a varnish is interesting. Usually the idea of taking a piece of wood and using like a fat or an oil or a resin, which is, these are all related to the water element, fat, oils, resin to lard, etc. And applying it to wood to waterproof it, or even metal to waterproof it, just anything. It's very interesting that you're using like a water element thing to make it resistant to water. So yeah, different properties have different. What would you say? Different materials have different properties, like waterproofing, fireproofing. There's a lot of fire retardants, they call them, that they add to like plastics and other stuff to make it so things don't catch on fire, and not very easily, or that are more puncture resistant. For example, you can probably make some kind of fabric which is puncture resistant. Like, I guess Kevlar's, isn't that like a specific special material? I don't know. So really, it's just you can use your imagination and you can create materials and create physical objects, and you look into the idea of casting or 3D printing. These are ways to make shapes in the world, to make physical objects. Because you think, like, how do you even make things? The old school way was you'd probably have like a brass or a bronze furnace, and an anvil and a hammer and some pliers and some other things, and you'd be making it out of brass, or you'd be casting it out of like tin or nickel or something. Or you'd be making something out of wood, like carving it out of wood. Maybe you need a wooden shape, or clay. So it does depend, of course, on the culture and the resources. Now we have basically, we have a lot of resources, but still you use what's cheap, essentially. Really, it's investigating into the physical world is as valuable as investigating into the physical world, as investigating into the spiritual world. Once you've learned the spiritual world, you can learn the physical world, and it's the same thing where you will just continuously keep learning how to do things, how things work, and you'll be quicker at learning all these things, and you'll just fill in the gaps of your knowledge. I mean, that's how you learn things, and you obsessively just go through everything and try to figure everything out. And it's important. It's like learning how society works. To function in society, you have to learn how society works. And of course, depending on the kind of person you are, will depend on the ways that you learn it and such. Yeah, I don't know. They're both important, physical and spiritual worlds. It's like you can't just be poor and live in a tent in the forest because you have to. If you want to do that, then go ahead. But I'm saying, because you can't pay your bills or whatever, it's not a good thing. You've got to learn how to build and how to sell and how to negotiate with people, and the energetic forces of the world. These are basic things to learn. People in the past made their own houses, they built their own furniture, they raised their own animals and grew their own food. They really did all that, and it's kind of a pain in the ass now because you have to buy land for stupid prices. So it kind of chainsawed the feet of the younger generations, but guess we can't just lay down and die and do nothing. So little by little we'll figure out these secrets of the past and all that kind of stuff. Anyway, I'll leave it there. You probably get the main point. Of course, have a good day, and check links in the description if you're interested in social and commercial things. Probably the best way to get hold of me if you want to is just DM me on Twitter or Gab, to be honest. Otherwise, have a good day.